Hello, this is Farhan Shakil from the Republic 2.0, and I'm back with the physics past paper, which is 8 PHO from the Pearson Edexcel May 2023. So first of all, in the part one of this video, I'm going to start with the multiple choices of this paper, P1, which mostly consist of the electricity and the mechanics. So first of all, we've got this question number one. And question number one says that a student throws a ball vertically upwards, which of the following shows a free body force diagram for the ball immediately after it leaves the student's hand. So since the student is, throwing a ball vertically upwards, and if he is throwing the ball vertically upwards, the only force acting on the ball is the downward, which is the gravity, right? So A cannot be the answer, B cannot be the answer because there is no upward force acting on the ball. The only force which is acting downward is going to be the gravity plus the air resistance, right? So that is why we have to go with the option number C. Similarly, for the question number two, which row of the table contains only scalar quantities? So everybody knows that scalar quantities are such quantities which require only magnitude for their propagation. So that is why, in the part A, displacement is a vector quantity. In the part B, momentum is a vector quantity. In part C, there is no vector quantity. Power is scalar, time is scalar, work done is scalar. So that is why we have to go with the option number C. In the question number three, he's talking about that a ball falls from rest through glycerine and reaches the terminal velocity. Which of the following graphs show how displacement varies with the time for the ball? So, initially the body would not be having any sort of terminal velocity. As it gains the velocity, there would be a time when the gradient of S and T should be very uniform. So that is why you have to keep it like, if you look at the option number A, the distance is constant, which means the body has a zero velocity and terminal velocity is not zero. So we're not going to go with A. Similarly, C is showing you a uniform gradient, but a body takes some time to reach the terminal velocity, so that is why we're not going to go with C. Same is the case with D because there is no uniform velocity. The only option that makes sense is B, right? So that is why we have to go with the option number B. In the question number four, a piece of a conducting putty is shaped into a cylinder of uniform cross-sectional area. The length is L and the resistance between the two ends is 8 ohms. So everybody knows that resistance is rho L upon A, and the value of resistance is given, and that is 8 ohms. And now the length has been doubled, and since we need to keep the volume constant, remember if you're doubling the length, your area should increase in such a way to keep the volume constant. So A times L is the volume. If you're doubling the length, you have to decrease the area by 2, so it would be V now. So now rho as it is, in place of length, I'm going to write 2L. In place of A, I'm going to write A upon 2 for the second one, right? For this one, keep it equal to 8 as well. And now I would be having, rho L divided by A times 4. Rho L upon A, the original resistance was 8. So, 8 times 4 has to be 32 ohms. So that is why I'm going to go with the option number D. Now you've got this option number 5. A car is traveling on a, in a straight line along a horizontal road. Which row of the table gives the Newton third law of pair of forces? So for this thingy, you have to go with the option number B, because they are the same forces acting on the different objects, which makes up the Newton third law of pair of forces, right? So that is why you have to go with the option number B. In question number 6, the diagram shows an electric motor pulling a truck of mass m along the slope. The truck moves a vertical height h and a distance l along the slope during the time t. There is a potential difference V across the motor and the current in the motor. So first of all, the the input power is going to be, the input power or even the input energy is going to be V times I times T. So that is the input. And the output energy by which this motor is pulling this mass up should be mg. And you can see that this mass is being pulled up by a height h. So you have to give it h. So the efficiency is going to be um, VIT, no, output, MGH divided by VIT. So that is why you have to go with the option number C. And now you have got this question number 7. A student investigated the EMF and internal resistance of the battery. The student produced the following sketch of the graph. Which row of the table gives the quantities plotted? So first of all, in the option number A and B, you've got this EMF. For example, this is EMF. And remember that EMF always remains constant. So that is why I'm not going to go with A. I'm not going to go with B. In the option number C, you've got the terminal potential difference and the circuit resistance. So, both are directly proportional to each other. So their graph could not look like this thingy. And now, but the D option, terminal potential difference and the current, it could be the only this thingy, terminal potential difference and the current. As you increase the current, the terminal potential difference decreases. So that is why you have to go with the option number D. Similarly, a ball is thrown vertically upwards at a velocity of 6 meters per second, which of the following gives the maximum height. So everybody knows that V square is equal to 2gh. You need to calculate the h, so V square upon 2g. Now you can see that the velocity is 6 square divided by 2 times 9.81. So that is why you have to go with the option number C. Did you get that? So that is how we're going to go with the option number 8. I'll be back in the next video, starting from the question number 9. Till then, thank you very much. That's it for today.